I'm here with Jesse Rowe of Summit Prep. You teach, what classes do you teach?
I teach algebra, geometry, and algebra 2.
And now you're with us, luckily, for the summer, doing a whole bunch of stuff as a teaching fellow.
Yeah, as a teaching fellow, I've been helping with organizing and developing new content, mostly on the exercise side of the site.
And the reason why we're doing this right now is you had some very interesting ideas or questions.
Yeah, so as an algebra teacher, when I introduce that concept of algebra to students, I get a lot of questions. One of those questions is, what's the difference between an equation and a function?
The difference between an equation versus a function. Well, it's an interesting question. Let's pause it and see. Let the viewers try to think about it a little bit, and then maybe we'll give a stab at it.
Sounds great. So Sal, how would you answer this question? What's the difference between an equation and a function?
Let me think about it a little bit. So let me think. I think there's probably equations that are not functions and functions that are not equations, and there are probably things that are both. So let me think of it that way. So let's first think of, so I'm going to draw, if this is the world of equations right over here, this is the world of equations, so this is equations, and then over here is the world of functions. That's the world of functions. I do think there is some overlap. We'll think it through, where the overlap is. The world of functions. So an equation that is not a function that's sitting out here, I think, a simple one would be something like x plus 3 is equal to 10. I'm not explicitly kind of talking about inputs and outputs or relationship between variables. I'm just stating an equivalence. The expression x plus 3 is equal to 10. So this, I think, traditionally would just be an equation, would not be a function. Functions essentially talk about relationships between variables. You get one or more input variables, and it will give you only one output variable, output value. And so you could have something like, and you can define a function, and I'll do that in a second. You could define a function as an equation, but you can define a function a whole bunch of ways. You can visually define a function, maybe as a graph. So something like this, and maybe I actually mark off the values. So that's 1, 2, 3. Those are the potential x values, and then on the vertical axis, I show what the value of my function is going to be, literally my function of x. Maybe that is 1, 2, 3, and maybe this function is defined for all non-negative values, so this is 0 of x. And so let me just draw, so this right over here, at least for what I've drawn so far, defines that function. I didn't even have to use an equal sign. If x is 2, at least the way I drew it, y is equal to 3. You give me that input, I gave you the value of only one output. So that would be a legitimate function definition. Another function definition would be very similar to what you do in a computer program. Something like, if you input the day, so let's say that you input the day of the week, and if day is equal to Monday, maybe you output cereal. So that's what we're going to eat that day, and otherwise you output meatloaf. So this would also be a function and we only have one output for any one day of the week. We're only saying we can only tell you cereal or meatloaf. There's no days where you are eating both cereal and meatloaf, which sounds kind of repulsive. And then if I were to think about something that could be an equation or a function, I guess the way I think about it is an equation is something that can be used to define a function. So for example, we could say that y is equal to 4x minus 10. This is a potential definition for defining y as a function of x. You give me any value of x, then I can find the corresponding value of y. So this is at least how I would think about it.